Section 5.1, still in Unit 4, is measures of dispersion. The range of a data set is the difference between the largest and smallest values in the set. So example 1, find the range of the heights of the people listed in the table. So we would take the largest data value, that is 107 inches. Minus the smallest data value, 26 inches. And that gives us 81 inches. Change that back to feet and inches to divide 81 by 12. You get 6 feet with 9 inches left over. Standard deviation. If X is a data value in a set whose mean is X bar, that's one way to denote the mean, X with the bar on top, then X minus X bar is called X's deviation from the mean. So the deviation from the mean is the difference between a data value and the mean. So here, the deviation, say, from 16 to the mean is 1 to the left. From 14 to the mean is 3 to the left, and so forth. Standard deviation is found with this formula. It's the square root of the sum. This E-looking thing is math's way of saying sum. So the sum of the square of the deviation, your data value minus the mean, over n minus 1. And so this takes a little bit of work. We use a table to help us get through it pretty quickly. So to compute the standard deviation, you can read through this. We're going to do it. Example 2 says, while planning for spring break, suppose you went to orbitz.com to find the cheapest flight from Philadelphia to Orlando and found the following prices. Find the standard deviation of this data set. So in this table here, I've listed the prices. And we're going to use the table to help guide us through finding the mean. Or not the mean, the standard deviation. And the standard deviation is, again, the square root of the sum of data values minus the mean squared divided by n minus 1. Well, the first thing we have to do is find the mean. So we're going to add up these values just like we did in the previous section. Divide by the number of them. There's 6. So we get 1260 divided by 6. The mean is 210. The second step is to subtract the mean from each data value. So we'll take 195 and subtract 210. And that gives us negative 15. For the next one, we'll take 213 and subtract 210. That gives us 3. Then 208 minus 210 gives us negative 2. And so forth, we get 9, 0, and 5. The third step is to find the square of each of those differences we just found. So we're going to take negative 15 and square it. We get 225, and that's positive because it's negative 15 times negative 15. Then 3 squared is 9. Negative 2 squared is 4. 9 squared is 81. 0 squared is 0. And 5 squared is 25. Then the next step is add the square and divide the sum by n minus 1. So what we're going to do is we're going to find the sum of all of these, okay? That's going to give us the sum of x minus x bar squared. It's 344. And then n was 6. So we'll plug in. We've got the square root of 344 divided by 6. That's the square root of 68.8, which is approximately 8.28. So the standard deviation is approximately 8.28. Example 3 says Anya is considering investing in Appeal, a software company that specializes in smartphone applications. She intends to compute the standard deviation of its recent prices to measure how steady its stock price has been recently. The following are the closing prices for the stock for the past 20 trading sessions. What's the standard deviation? So we're going to do the same thing. Now, or very similar, but in this case, we like the 37 is just listed once. So we're putting frequency there. And 38 is listed twice. $39 is listed 5 times. $40 is listed 4 times. No, I missed one. 5 times. $41 is listed 4 times. Then 42 is listed twice. There wasn't a 43 at all. And 44 is listed once. Okay, so if we've got a frequency like this, then the next step is to find the product of our data value times the frequency. So 37 times 1. 38 times 2. 76. 39 times 5. 195. 40 times 5, 200, and so forth. 41 times 4 is 164. 42 times 2 is 84. And 44 times 1 is just 44. Then we find the deviation. So, well, first we have to find the mean. Okay, so let's do that. The mean, if you add all these up from the previous page, or you could add these, you get 800, and there were 20 of them, so the mean is 40. And so we'll subtract each data value minus 40. 37 minus 40 is negative 3. 38 minus 40 is negative 2. Then 39 minus 40 is negative 1. And so forth. So 40 minus 40 is just 0. 41 minus 40 is 1. 42 minus 40 is 2. And 44 minus 40 is 4. Then we go and we square them, just like we did before. So we have negative 3 squared is 9. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 4 squared is 16. Next step, take that number and go back and multiply it by the frequency. So we have 9 times 1 is 9. 4 times 2 is 8. 1 times 5 is 5. 0 times 5 is 0. 1 times 4 is 4. 2 times 4 is 8. And 1 times 16 is 16. Then we add them all. And that gives us 50. Now we can find our standard deviation. And here's what this formula looks like. It's the square root of the sum of the data value minus the mean squared times the frequency and divided by n minus 1. So we've found our sum, that was 50. N minus 1, n was 20. So that gives us 50, taking the square root of 50 divided by 19, approximately 1.62. So that kind of tells her that the stock hasn't fluctuated too much. And there's that formula again. All three of these distributions have a mean and median of 5. However, as the spread of the distribution increases, so does the standard deviation. So you can see a smaller spread has a smaller standard deviation. This spread just goes from 3.5 to a little less than 6.5. Well, this one goes to a little over 2.5 to a little over 7. And the standard deviation is bigger. And this one, I think that's actually 2 to 8. And the standard deviation is even bigger. The coefficient of variation we denote by this. The standard deviation divided by the mean times 100. And that should have, that X right there should have a bar over it. I better change that in our notes. Okay. So find the coefficient of variation and determine whether Facebook or Twitter had more consistent closing stock prices during the first 6 months of 2016. The mean closing price, they've given us the mean and the standard deviation, so we didn't have to go through and do all that, which we've done before. Okay? So, for Facebook, it would be S over X bar times 100%. So the standard deviation for Facebook was 4.67. And the mean, 114.73. Gives us 4.07%. And then for Twitter, the standard deviation is 1.33. The mean is 16.06. We get 8.28%. And that's it for this section.